So this is a maximum high availability architecture with MySQL Enterprise Edition. Bear in mind that this is not a solution for every project, every installation, and so on. But this is kind of like give the reference architecture how to use MySQL InnoDB cluster to achieve the highest SLA in terms of high availability as possible. Okay. So what it takes to have high availability. So general requirement, always have redundancies, no single point of failure. So we need to have hardware and software redundancy. We need to have data redundancy. We need to have application and service redundancies, as well as we need to have mechanism to do automatic failure detection and automatic recovery. How to recover from failures, that's also important. That's high availability. So what is MySQL response for these requirements? First, we use InnoDB cluster. It is shared nothing architecture. Okay, there is no part in the InnoDB cluster that's shared between one InnoDB cluster member with another InnoDB cluster member. And then we use database replication for redundancy with guaranteed consistency. So it is not master-slave. Okay, it's not source replica because source replica either using semi-sync or asynchronous replication. It is not 100% consistency guaranteed. But InnoDB cluster is guaranteed consistency. And then we have a rolling upgrade and patching. And we also have transparent database connection for auto failover and load balancing as well. Okay, because InnoDB cluster, okay, it is shared nothing architecture, meaning that in one cluster it has more than one database nodes. Then how application is going to, which node application is need to connect, right? So we have later on we have MySQL routers, okay, for transparent DB connection. So application does not need to know about database cluster topology. And InnoDB cluster provides split brain prevention, failure detection, and self-recovering from failure. So about InnoDB cluster, okay, so InnoDB cluster is shared nothing architecture. It consists of minimum 3 nodes, okay, and then they are replicating each other, okay, but one node become a primary because we suggest to use single primary mode, one node as primary, okay. Primary meaning that super read only equal to off, meaning that we can do a read and write as well. And 2 secondaries, okay, the secondaries will running on super read only equal to on, meaning it is running on read only. An application need to connect to a router, okay. We have a read-write port, okay. If application connect to read-write port, then the connections will be diverted into the primary. So the routers also have a read-only port. If application connect to routers using read-only port, the route connection will be diverted into the secondary. We also have a read-write split. The read-write split is like actually application does not need to change connection from read-write to read-only, okay, but read-write split will make a decision, okay, based on the SQL query, whether you select, update, delete, and so on, yeah, keywords. So if this is the DML, okay, and the connections, the execution of the query will be running on a primary. But if it's normal select, then execution of the query, SQL statements will be on a secondary node. If the primary node fail, yeah, then there is a mechanism to do automatic failover. The InnoDB clusters will promote one of the secondary node become a primary, okay, and the application does not need to know. What application need to do is to connect, yeah, reconnect to the MySQL router, and MySQL router will divert the connection to the new primary. If the failed nodes recover, it will join back to the InnoDB cluster automatically. So DBA can just sit back and relax, yeah, theoretically like that. So it will automatic, healing, and then auto rejoin to the secondary node. Remember that this is automatic rejoin sometimes, okay? It's just normal simple recovery, or sometimes it require distributed recovery, okay? In previous talk, yeah, I mentioned, okay, we can split between data LAN and recovery LAN, yeah, private LAN. With 3 nodes InnoDB cluster, it is able to handle 1 node failure, okay? 5 node InnoDB cluster able to handle 2 node failure, because InnoDB cluster, okay, can need to have a majority of node members to be available. Let's say if you have 5, then 2 node failure, meaning it's still 3. Majority of 5 is 3 is the majority of 5. Yeah? But if you lose 2 nodes, then only 1. 1 is not the majority numbers for 3 node InnoDB clusters. Okay, so only 1 can fail. Yeah, for the clusters to work. I already explained about this. The left one is actually the normal InnoDB cluster setup that we always see. Okay, the second one is actually the advanced setup, where we split between data LAN and recovery LAN. Okay, we split between data LAN and private LAN. Yeah, the private LAN can be, we use this private LAN, okay, for InnoDB cluster communication between members and for distributed recovery. Yeah, for the node to be able to rejoin back to the cluster if there is any failure, so that there is no, data can, LAN can be segregated. And this is MySQL routers. Okay, as I mentioned, it is going to be like, is a crucial component of the InnoDB clusters for the applications to connect InnoDB cluster transparently. So the application does not need to know where is a primary, where is a secondary. Everything is handled by MySQL router. So how to install MySQL routers now? There are 2 deployment models. Okay, I call it as distributed, meaning that MySQL router is distributed amongst the application server. So each of the application server will have its own MySQL router. So imagine that you run application server. Okay, you need to provide high availability on the application server. Application server is stateless. That means you don't have to create a high availability whatsoever. You need to have more than one server, and then you run your application server, your server, okay, in all those nodes, yeah, because it is stateless, and your application, okay, can connect to a local InnoDB cluster, local MySQL router, yeah. So the connection is no longer connect to the remote database server or database servers that are on the networks, but connection is local. You can use local host or you can use 127.0.0.1, okay. The second one is centralized. If you want to centralize the application, MySQL routers, okay, you can install MySQL routers in a separate VM. Okay, then you need to create your own high availability. I recommend to use Oracle Linux. Yeah, why? Because Oracle Linux have high availability setup using chorusing. Yeah, the chorusing is supported by Oracle. It will provide the VIP. Okay, and then VIP failover as well. And then MySQL routers, at least if you run on productions, okay, please size up your MySQL router correctly. Because if your MySQL router is running on distributed model, it's only need to have additional one vCPU because it is just a distributed model. But imagine that you have 4, 5, 6 application connecting the same router, then you need to have a CPU capacity also in the MySQL routers. Okay, even though router is lightweight, okay, please treat it as important as the database, okay, because it is providing the application, the way for the application to connect to the InnoDB cluster. Okay, in distributed, if the application server is failing, okay, you don't have to worry because another application server still still running and connecting to MySQL routers. But in centralized models, if the MySQL routers server is failing, then okay, the chorusing will actually do the orchestration to fail over the VIP into another MySQL router so that the applications will be able to reconnect to InnoDB cluster to new MySQL router hosts. Yeah. And then on top of that, we also have read replicas. The read replicas is actually not part of the InnoDB cluster group replications, but it is part of the completely a total solution. Okay, why it is part of the solution? Because it has admin API. If you see, if you actually check the status of InnoDB cluster, then you will see the read replicas over there. Okay, this read replica usually, if you set up for the first time, it will actually become a child of the primary. But you can always change. Okay, I don't want the read replicas to be a child of primary. I want to read replica to be a child of one of secondary node. That's fine. You can do it using admin API. The read replicas is not part of the InnoDB cluster group replication because there is asynchronous replication between one of the InnoDB cluster member into the read replicas. Meaning what? Meaning if we actually run heavy query in the read replicas, consume a lot of CPU, the InnoDB cluster will still be healthy. Remember about flow control that we talked about just now? The flow control is actually, make sure that there is no replication lag. Okay, but if you have heavy queries concurrent into the one of the InnoDB cluster member, so the CPU will get occupied, the memory will get occupied. That node becomes slow and slow and slow and slow. Replication lag will be happen, and flow control will throttle the transactions. Okay, that's why it's very, very important. If we have heavy query, we provide the read replicas. For those heavy query that happening from the application. We also have a delayed replication. Delayed replication will deliberate execute transaction later than source. Okay, we can delay. It doesn't mean that it doesn't have data. Yes, the data is there, the bin log is there, but the commit point will be delayed. Okay, how long it will delay is up to you. You can delay 1 hour, you can delay 2 hours, you can delay 3 hours, whatever it is. It is very, very important to know that even though this is physically highly available, but logically it is still single one database. Let's say you say that, okay, InnoDB cluster, I already have a HA. Okay, one developer came in, okay, junior one, truncate customer table. All the tables will get truncated. Even though we have more than one database, all will truncated because it is eventual consistency, right? But at least we have delayed replication to survive, for us to recover the data, because the data that truncated into the main InnoDB clusters in delayed replication will still be there. Okay, this is actually very useful for recover from the logical corruption. So how about if we want to achieve the maximum high availability? This is so-called the architecture building blocks. Okay, for InnoDB cluster, we can extend into the disaster recovery side using InnoDB cluster set. What is cluster set? Cluster set is set of cluster. So we deal with more than one InnoDB cluster. We club together into one solution. And between primary cluster and replica cluster, we have asynchronous replication. And this is standard setup, basically. Okay? And MySQL routers will recognize this setup. MySQL router will understand the whole entire nodes, whether it is on primary cluster or replica cluster. And then here, I have 3 read replicas. I have 1 delayed replication to avoid, logical corruption. I mean, not to avoid, to recover from the logical corruption. Okay, these 3 replicas. Why 3? Okay, I will explain later. Okay, because this is a 3-node InnoDB cluster. Okay, if we do patching, okay, I explain now. In 3-node InnoDB cluster, if we do patching, then I need to shut down one of the nodes, right? And then the goal of having maximum HA will not be achieved. Why? Because at that point in time when I actually patching that, my database HA no longer, because it only have 2. I cannot survive if I'm doing patching on 3rd node and 2nd node crash. Then the entire cluster gone. Where is the maximum HA? No. So that's why we have 3 read replicas. The idea is actually to bring these 2 replicas, promote into the InnoDB cluster, become 5. So that when I do a patching on a 3rd node, 2nd node gone, suddenly crash, I still survive because I have 5 node InnoDB cluster temporarily. Okay, because a 5 node can able to survive 2, to crash. Then once the cluster, the patching done, then I do demotion of this 2-node InnoDB cluster back to read replica. Okay. Okay, so this is the high availability building blocks. We have InnoDB cluster set 3 plus 3, 3-node InnoDB cluster primary, 3-node InnoDB cluster replica. We have MySQL routers, enterprise backup, delayed replication, MySQL shell dump load, okay, and then read replicas, thread pool, and so on. This is failure handling. Let's say scenario 1, secondary node and read replica suddenly gone, suddenly crash. No need to do anything, okay? There is no impact on HA. Okay, primary node failure handling. Okay, this is also automatic. If the primary node fail, then it will automatically, the primary will automatically move to one of the secondary node. Okay, it will promote automatically secondary node into primary. How about the asynchronous replication? Also, asynchronous replication in the InnoDB cluster set, it will also change automatically. Okay, remember that in InnoDB cluster set, primary node for this one, primary cluster and replica cluster is always having asynchronous replications. But if the primary node down, the asynchronous replication also, follow the new primary. And as you see, the entire process is automatic. There is no manual, activity need to be done to avoid that. To recover that. But how about if we lost 2 nodes, suddenly crash? Then yes, okay, we need to do force quorum using partition off to make this new primary able to, back to become a primary again. Because if we lose a majority, suddenly the cluster will, so-called it's not crash, but actually the cluster will not working. Okay, the transaction will stop. Router will not redirect the transaction, and then primary will become read-only. So that's why we need to use force quorum using partition off to enable the cluster back. Yes, there will be a manual process over there. And then, if we have a logical corruption, okay, junior DBA or junior developer drop a customer table or truncate customer table. Even though we have all the server, okay, one mistake, it will drop or truncate the entire server, database server. And what we need to do? We need to restore one by one, right? But if we have a delayed replication, it's easy. We can just stop replication, okay, in the delayed replication, export using MySQL shell, okay, and then import into the primary to recover the data. Because the delayed replication will delay the executions of the transaction. Disaster recovery handling. Okay, if we have, normally the company have a so-called DR exercise, okay, where they want to switch the operation into the disaster recovery side. Okay, in InnoDB cluster set, it's very easy. We just need to manually, okay, execute command set primary cluster, okay, to switch the primary cluster to replica cluster. Then all the operation will switch. Okay, we don't need to install routers. We don't need to reconfigure the routers because routers understand. It will also change the connections, okay, from to this cluster into the right cluster. Okay, the primary cluster is moving to DR side, and everything will be like just one command. Everything will get executed automatically. So if the primary is shut down, then you can easily use force primary cluster to make this DR side to become a primary cluster. Again, the application does not need to change anything. Router does not need to change anything. What you need is actually to do one command, force primary cluster. Okay. Okay. For recovery, okay, once the DC side up and running, yeah, we can have this, and then we can run command rejoin cluster to rejoin back this cluster into the cluster set, and suddenly it will join back as a replica cluster. And once it is joined back as a replica cluster, we don't need to activate the replication channel. Okay, it will activate it automatically, the asynchronous replication from the RC to DC. That one is also automatic using this one simple command rejoin cluster. Everything is orchestrated. How about patching? Remember, this is for a maximum high availability, right? So we cannot have one node patch and suddenly this one crash and everything gone, right? So of course, if 2 nodes suddenly crash, yeah, we cannot do anything, okay? But if this is a planned activity, it's on us, okay? So that's why we can actually promote the cluster. We can promote the two nodes from the read replicas to become InnoDB cluster. Okay, but for doing a patching, we need to do it one by one. We need to do a rolling patch. Okay, so how to do is basically start with read replica first. because read replica doesn't affect any HA over here, right? So all read replicas and delete replication we need to upgrade. And then we support replication from lower version to higher version, not vice versa, okay? But lower version to higher version we support. That's why we can easily upgrade all the read replicas. Once all the read replicas are upgraded, then what we need to do is basically to do rolling patching on the primary cluster, let's say. Or maybe in replica clusters first, yeah, because the replica cluster need to have a higher version. So the way to do is basically to promote this one or two read replica into become secondary node of the InnoDB cluster. So that if we do a patching, if one of the node fail, then the cluster will still be up and running, survive. Okay. So yeah, this is a key takeaway. High availability and disaster recovery is an absolute requirement for business today. We require operation around the clock. And then MySQL high availability architecture provide blueprint, okay, to meet our RTO and RPO requirement. And MySQL InnoDB cluster set can be utilized to optimize, business continuity. Optimize meaning that it will streamline the operations, okay, for business continuity. If one site down, one site failure, or company want to have like, the drill or running business operation on disaster recovery side, switch, something like that. Okay, we have very handy admin API command to do that. Okay, both plant maintenance and outage, even it is across a data center. Thank you.